So yesterday we have started pointers. We have discussed few things about pointers, like what are pointers and problems with the pointers, size of the pointer we have seen. Then why pointers have data type. We saw this. So let us continue. That is our next topic is, yes, parameter passing. Parameter passing. See, in C programming, there are two methods of parameter passing. That is pass by value, or it is also called as call by value or pass by value. And the second one is pass by address or reference also. But I'll take one more third one that is coming from C++, that is pass by reference. I'll cover all three. In some gate questions, they have used the syntax of pass by reference of C++. But they have given the complete description. What does it mean and all? All right, they have explained what it is and used it. See, there are few things they expect that you already know it. And there are few things that the thing that you don't know, so they'll explain it and then ask question. Right, so as C language is there, so pass by reference of C++ is not there. Anyway, let us look at these three methods: pass by value, pass by address, and pass by reference. Three methods are there supported by C language. So let us write one example function. Suppose I have a main function. So first I am explaining pass by value. I have a main function. In this, I have some variable a, which is having value 10. Then I am calling one function and passing the value a. And then I will print the value of a. So this is a function. I'll write void function fun, which takes a parameter x, and it will print x. I'm not writing complete printf everything. It's mean printf percentile d x. Then it will do x plus plus. Then again it will say print x. Now, this is just an example piece of code to explain you call by value. So actually I have to explain you the working behind this one. So first of all, the working of the code, then what happens at the back also I will explain you. So let us look at this code. See, function main is having one variable a having value 10. Then it will call the function fun and pass the parameter a, the value of a. Value of a is passed to this one. So later on it is printing. So we'll come to printing later. So here if you see function a, function fun is taking a parameter with name x, So whatever the value of a is, that is copied in x. So the value 10 is copied in this one. So if I draw a diagram here, so this is having a value 10, and as it is a variable, a is a variable having value 10. Let us say its address is 200. So when we draw a variable, we will also write down the address also, so that if required, we can use the address. Now, when this is calling a function fun, so its own activation record is created and its own variable is created. So let us say the address is 300. Maybe far away, just random address I am writing. Okay. Then what happens here is value of a is copied in this one. So the value 10 is copied in this one. So what is passed? Value of this parameter is passed. Value of this parameter is passed. Then here, print x. So print x means what is printed? 10. Then x plus plus, so this becomes 11. Then again print. So what is printed? 11. Now function ends its activation record is deleted, the control goes back to main, and here, next line is what? Print A. So what is printed? 10. All right. So the value of A is not changed. The value of A is not changed because what was sent from here, just the value of A was sent to X, and X has a change inside the function. So actual value is not changed. Now, to describe this one, I will take two terms less than this one. See, when you're passing this parameter, this is called as actual parameter. And this function is taking a parameter, and this is called as formal parameter. See, listen. Fun of A. Now you have to answer. Fun of A. A is a parameter. Parameter, right? Okay, in general terms, parameter. Fun of int x. What is x? Parameter. So that also parameter, this also parameter. So there should be some distinction between them. So we give the name. This is the actual parameter. And that is the formal parameter. Formal means this is the actual value. And that formal means what? When you pass it, it will take it and perform operation and close, finish. So that is formally created. So this is actual parameter and the formal parameter. Now, let us describe what is call by value. Listen carefully. In call by value method, the value of the actual parameter is copied inside formal parameter. And if any changes are done to the formal parameter, that will not affect actual parameter. That's it. And what is the syntax for passing? Just you have to say A and just you have to say X here. That's all. All right. So once again, I am repeating so you can note down. This is call by value method. In call by value method, the value of actual parameter is passed to the formal parameter. If any changes done inside the function to the formal parameter, that will not reflect into the actual parameters. Those value remain same. So you can take this one. So in C language, call by address is also called as call by reference. But in C++, call by address is different, call by reference is different. So in my topic, I am calling in C language, I am calling it as call by address only. Though you can call it as reference also, just stick to address. So reference, I have taken it from C++. So I'll discuss that also. Uh-huh. Argument. That argument is the same thing. Parameter, yeah. Hmm. Argument means it is used for both, actually. Used for both. I'll tell you. I'll tell you that. Literal meaning I'll give you, then we will decide what we should call. So I'll bring it into discussion. Okay, finished. Now I have to explain call by address. But somebody asked a question, so based on that, I will tell you the question and also we will discuss on it. What does it mean by parameter? The meaning of word parameter. Leave this one. In general, parameter means what? Factors that affect the working of something, parameters. So the working of this function depends on this value. So that is a parameter. No, no, leave the word argument. Parameter means what? Which decides the working of factors upon which the working depends. Right? So I'm just taking the literal meaning of parameter and explaining you something. Okay. So literal meaning of parameter in general, what are the parameters? You'll ask. What are the parameters in general terms? Suppose we will do this, but what are the parameters? These are the factors. Factors means upon these things, our deal, our process, whatever it is based on these values or these things. So what is the working of this function? That depends on that value. It's called as parameter. Understood? That's why we are using the word parameter here. From dictionary, we have taken a word and using it here. Understood this one? Now, this is also parameter, but this is past. This is taken. So we say this is actual parameter. That is formal parameter. Over. Now, argument means what? No, no, leave the programming part. Dictionary meaning I'm asking. English dictionary meaning. Argument means what? Arguing. Arguing means asking for. Arguing means, no, that argument means fight. But arguing means what? I'm arguing for this means I'm asking this one. I'm asking this one. Now, what that function is arguing for or fighting for, requesting for value. So that's the argument. That's the argument. In that sense, we use word argument, I am telling you, nothing else. Okay. See, parameter, argument. What is argument, sir? What is parameter, sir? So actually, I have taken the words and given the literal meaning. Then I have shown you the why the words are used here. That's all. That is called as argument. Now, when you pass, these are the values that you're passing. It's asking for x. Okay, take x. So you're passing a value here. But this is also called as argument because you're passing the arguments. So parameters and arguments are synonyms in programming. In programming. Understood this one? All right. So actually he asked what are parameters, argument also we can say. So that's what I wanted to convey this, that argument and parameter are synonym. Then why two different words? So I'm just giving the meaning of that. In what sense the words are used. Okay, this is the sense behind that. Chalo, leave it. Now I have to talk about oh, call by address. Call by address. Watch this. Just I am writing a sample piece of code to explain the working of this one. So I have a main function. I have a variable having value 10. And from here, okay, I have one function, void, and this function takes integer star p. So it's taking parameter what? Address. So it's a pointer variable or address variable. It's taking its argument is pointer. Then here it will do what? Print asterisk p, then asterisk p in bracket, I will say plus plus, then again print asterisk p. Similar code, but I have changed with the pointer. Now, when you are calling the function, you will be passing what? Not a, but you will be passing what? Address of a. And after calling the function, if you print a, what happens? We will see this. Now let us watch and see the working of this one. See, when the main function is called first, so the variable a is created. Variable a is created and it's having value 10. Let us assume that its address is 200. Now we are calling a function fun. So this p is a variable. And p is a variable, and it's also having its own address. Let us say it is having its own address 300. Like, it's an address variable. So it is also a variable, so it will also have its own address. This is inside whose activation record? Mains activation. This is inside whose activation record? Function funds activation record. From here, we are passing not A, we are not passing 10, we are passing address of A. So 200 is copied in this one. So 200 is copied in this one. So in this way, this is having the address of this location, the address of this location. So that pointer is having the address of this location. All right. Now, coming to this function. Now function is called print star p. So if you say print p, it is 200. But if you say print star p, it will go to this location and take the data and print 10. Then star p plus plus. Achha, if you say just p plus plus, this 200 will modify. But if you say star p, it will go to this location and say plus plus. So this value changes, 11. 11. Then again, when you say print star p, so it will go to this location and take the value there. So that is 11. Now function ends, this activation record is deleted, it's gone. Then it will come back to this main. Now print a. What is the value of a now? 11. All right. Now look at this. One more thing I have told you. One more thing I have to show you. Watch this. This is a code section. All right. And this is the stack. This is the stack. Now, this is the activation record for main function, and it's having one variable, let us say a. And this is the activation record of function fun, which is having its own variable, let us say p. Now, before defining this one, I have to give the description. Before that, I have one question here. This activation record belongs to main. This activation record belongs to fun. Now the question is, can one function access the activation record of other functions? No. Can one function directly access the activation record of another function? No. But it is possible, not directly, it is possible indirectly. How? The function should pass the address of its variable, then only it can access it. So that is possible using call by address. Call by address. So I have added one more point here. That is important. So we learn one more thing here, that one function cannot access the activation record or the variables of another function directly, but it can do it indirectly if the address is passed to them. Now coming to this is called as what? Actual parameter. Actual parameter. All right. Now what is this called as? Formal parameter. Now let us describe call by address. In call by address, the address of the actual parameter is passed, and the formal parameter is always a pointer. Formal parameter is always a pointer. And using the pointer, it can access value of actual parameter. Any changes done to the, changes can be done to the actual parameter within a function. All right. Any changes done to the value will reflect into the actual parameter. Other words, you can say that. So once again, I am repeating, in call by address, the formal parameter is the address of the variables, and the actual parameter is the address of the variable. Formal parameter is always a pointer, and using the pointer for in the formal parameter, it can modify the data of actual parameter. It can modify the data of actual parameter. Now, if it needs, it will modify. It doesn't need, it will not modify, but it is possible. All right. So now, important thing, what is the syntax? This must be star. And here you must pass. This is very important. So this is a very tricky thing. Based on this, they have asked multiple gate questions. Listen, here ampersand must be there. If you don't write ampersand, it's an error. It's an error. We can't say what the error is, all right? But it's an error. You have to pass ampersand because it's taking an address. Then this is asterisk. And for accessing data, everywhere you should use star. All right? Everywhere you should use star if you want to access data. If you want to access address, just say PPP. But if you want to access data, star is there. Just on this point, 2-3 gate questions are there. Syntax. So are you able to read the syntax thoroughly or not? If you can't read it, you will give a wrong answer. So that's it. There is ampersand, there is a star, and for accessing data, star is required. If a star is not there, means you are not accessing data. If you want to make a note, you can make a note also for reference later on. Okay, Suman. In from here in pointers, what all you are learning, syntax is very important. So you should read it thoroughly, then you can. You should know the clear syntax. Many gate questions are designed based on the syntax only. Uh-huh. Yes, 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 yes. Right. We are not. No, memory leak. I didn't say memory leak. No, no, he asked some. He said it will lose the reference. He asked. Actually, his question was, if you don't write bracket, pointer will increment. Pointer will move to the next location. Means it's pointing on 200 now. As if integer is two bytes, it will point on 202. That was his question. So I said yes. So bracket is important there if you really want to modify the data. Hmm. If you don't use bracket, if you use bracket, all those things are coming next. So that's a lengthy topic. So I wanted to finish parameter passing. So then we'll start pointer arithmetic with array, with two-dimensional array, pointer to a function. So just pointer, 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 pointer today. Okay. So this parameter passing, we have seen two methods. Do one thing. Yeah. Listen, finished? We have to see the call by reference of C++. That is a separate topic. But how they use in gate questions, I am showing you that. They don't use actual method of C++, but they use call by reference. They will say that, okay? They will describe everything. When you see the questions, you can understand. See, they'll say that void function fun, integer p, and whatever it is doing. Then here is main, and integer a assigned 10, and function fun just a. This syntax belongs to which type of syntax? This is call by value or call by address? Call by value, call by value. But in explanation, they say that p is a reference to a. Reference to a. Syntax is call by value. But in description, they have given that P is a reference to A. Now, okay, one more thing. I can add a syntax here. I can add something here. Now something is happening here, then he will say p plus plus and something more. Now, when you say p plus plus, whose value is changed? A value is changed. They use the syntax like this. No new syntax. Actually, it's call by value only. But in the description, he will mention that if, sorry, P is a reference to, don't say, he will not say assume also, nothing. P is a reference to A. So you have to take it as a reference. So the behavior will be same as call by address. Call by address. Understood this one? All right. Now, one more thing I will tell you. In gate questions, if you are writing proper C language code without any syntax error, in the beginning, they will mention in the code question itself that the given C program code, the question starts like this. In this given C program below, this is what you have to find out, or what is the output. They will mention that. Otherwise, just say they will say that in the given code, they will say. In the given code means it's not C code, it's a pseudo code like. Understood this one? Got it? So this is pseudocode. Pseudocode. So pseudocode, how to read it? They will describe. Without that, they cannot ask a question. They will not ask at all. That's all. Just an idea I have given you. Don't note. Don't take the note of this one. Okay? This is now one more time. One more method. I'll just use other color just to make a change here. They will also sometime write ampersand here. There they will write ampersand. That's it. And again, they will say P is a reference. They will say that. What it is, they will say that because it's not a C language syntax. They will say that. All right? Is it clear? That's enough. Huh. He said, no, P is a reference. Reference means address or reference are the same thing only. So, that's what. When he said, see, in gate question, when he said P is a reference to A means if any changes done to P that are changing A. This is not C syntax. When he said that, it means if any changes done to P, it's changing A. So you don't have to write star or anything. All right? Understood this one? Now, let us go to C++. Now watch this. This is interesting. Call by a reference in C++. So before understanding call by reference, we should understand what is a reference in C++. Because in C++, address is separate, reference is separate. Okay? So I'll show you the difference. Watch here. I have one variable, integer A, assign value 10. Watch it. Don't copy. You have to listen carefully. This is suppose 200. This is which type of variable? Data variable. Data variable. All right, over. Now, next, integer star P, assign ampersand A. So, P, its own address, let us say 300, and then it will have the address 200, so it will be referring to this one. This is a which type of variable? Address variable or pointer? Pointer having the address of A. Till here you know. Now look at the syntax of C++. Integer R, assign A. I have not completed. R is which type of variable? Data variable. Data variable. This is pointer variable. How do you say this is a pointer variable? Because star is there. Huh. So actually, this is a reference in C++. So for reference, for pointer, star is there. For reference, ampersand is used. Integer ampersand A. So R is a reference to A. Listen carefully. R is a reference to A. So now you have three different syntax. A variable without anything in prefix. Right? Here, star is there. So it's a pointer. Ampersand is there. It's a reference. All right, reference. Now next. When A means memory is created and values is stored. When P means memory is created and the address is stored. Then R means what is done? alias, another name, nickname, another name. Now you can call A as R also. What is the address of A? What is the address of R? What is the value of A? What is the value of R? 10. Acha, R, is it consuming extra memory? No, it's not consuming extra memory. So there's a new syntax in C++. If you are aware of that, then you may be knowing it thoroughly. All right. So if you have learned only C or don't know C++, then there's a new thing for you. So there's a new type of syntax in C++. Call by value, call by address, call by reference. Now watch. Same program which I have shown you in the previous slides, same program, I will write it using call by reference. So look at it carefully. Main integer a 10, then okay, here I will write on the function void fun, and here integer ampersand r, then print r, then r plus plus, then print r, then here call function fun by just a, and then print a. Now same code, but what is the change in the syntax? This is just like which parameter passing method? This is just like call by value. And here ampersand is written. And when ampersand is written, you don't have to write star also here. Percent, nothing. Star you don't have to, asterisk you don't have to use. So does the syntax look simple? Syntax is simple. So the benefit of call by reference in C++ is that syntax is simple. But it works just like call by address. Works as call by address. Let us look at the working. Now let us look at the working. A is created, and its value is 10. Let us say its address is 200. Now the function is called R is a reference to A. It's the same thing, same variable. Now print R, value 10. R plus plus, same value is modified. Print R, value is 11. Now function ends. So this reference is of no use now. No separate memory was created for reference, right? Now when it comes back, now next is print A. So what's the value of A? 11. So the behavior is same as call by address, but the syntax is made simple. And when you come to call by address, the pointer also consumes memory and it stores the address, and it is indirect access. It's indirect access. But this one is becoming just like direct access. It is becoming, this is becoming a direct access. Understood this one? Over. Now let me finish this one. So simplest part is what? The syntax is very simple. All right. C++ has given it. So why C++ introduced this one? To make the syntax of, which one? Call by address simple. Syntax is simple. Now, if you have objects and passing them, then you don't have to use arrow, you have to use dot. You can use dot in C++. So syntactically, everything becomes simple and easy. All right, over, everything is over. So syntax is very important. Now, if you go back to this one, I said sometime they write ampersand and say this one. So this is called by reference of C++ only. Same as that only, right? Any confusion now? No, not address, not reference. No, this is a reference. Hmm. If you write asterisk, then you have to send ampersand from here. If you write ampersand R in formal parameter, then just the variable name. So that's the syntax. Yes, that's the syntax. Change in the syntax. All right. Understood this one? Got it? So it's just a matter of how you write it. So anyway, chill. Yeah, here I told you that in gate questions, they will give the syntax like this. So when you're writing ampersand means it's same as C++ syntax. If they don't write ampersand also, they say P is a reference. Without that also, then you have to treat it as a reference only. All right. Now, look at this one. In call by value, I'm repeating the things once again. In call by value, everything is normal. Just A, here also X. Separate memory, separate memory. Function ends, gone. No changes here. Call by address. The change is from here you should pass ampersand the address of a variable. Address of a variable, pass it. And the receiver end must be a pointer. Receiver end must be a pointer. And when you have a pointer means a star is required. And when you are accessing data, you must use star every time. So this is little complex syntax. Syntax is little complex. From here ampersand, there star, every time star, 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 star. For accessing the data, you have to go on writing that one. So in C++, they have given a simple syntax. What is that? See, if you remove ampersand from here, everything is just like call by value only. Now look at this. I have explained you what does it mean by reference. Once again, I'm repeating. So you can declare the variable just by giving name, that is data variable. You can declare variable with a name prefixed by asterisk, so it's a pointer variable, address variable. And you can also declare variable that is starting with ampersand. So that's a reference variable. So third type of variable in C++. So when you have a normal variable, you can store the data. You have an address variable, you need to store the address. When you have a reference variable, just you have to show to which variable it should refer. To which variable it should refer. So we are saying that it should refer to A. It should refer to A. So this doesn't mean the value of A is copied in this one. We are saying that, okay, let us say like this. I want to give an alias to somebody. Okay. Let us give an alias. Bantu. Bunty. We will call Bunty now, from now onwards. To whom? To whom you want to call Bunty? To him. So I want an address variable. Possible or not? I'm explaining something extra here. Listen, listen. Can you declare a variable like this? I want an address variable. Okay, address variable is created. Whose address it should have? I'll tell you later. In next line, I will say P assign ampersand A. Then it will be referring to A. Can you break it into two lines? Okay, leave it, leave it, leave it. So I'll come to this discussion afterwards. Okay. Okay. Chalo. Let us, I was revising this one. Once again, revise it. So this is a reference ampersand R. This is assigned with A. Assigned with A. Okay. So A is a reference to, sorry, R is a reference to A. So R and A means the same thing. So the same syntax we are using in here for passing the parameter. When you pass A, you don't have to say ampersand, nothing you have to say. So just like that, A assigned to this one. A is referred by R. A is referred by R. So that R means A only. Wherever it is accessing, same thing will access. Over. So copy this one, then I explain you something more in that one. So I have explained you what does it mean by reference. So you have to note down what a reference is a nickname of a variable. When you are declaring a reference, you must assign some variable name. So this A and R are the same thing only. So that same method you can use in parameter passing. That will be easier in syntax. Easy for writing and reading the code. That's what C++ has done. Shankar, very good question. I'll answer it. P++ with ingredient value of no, P++, Chandan, it was asterisk P++. Just it was not just P++. It was asterisk in bracket then P++. So it will increase the value, not the address. Sir, in call by reference of C++, how fun is directly accessing the act? Lokesh, very good question. Yes, that's the next discussion we will have. Shankar has asked a question that is similar to Lokesh question. Hmm. Over. Now, let us go to next slide. Now, see this. Can you write down the syntax? A new thing we are learning. Okay. Can you write down a syntax like this? Is it correct? Declaration of a integer type variable a. Then a assigned 10. What is this? Initialization of a. Okay. Second. Can you write down the line like this? Yes. Declaration of a pointer variable p of type integer. Then, okay, here a was created. Then later the value was 10. Here p is created. Now next line I will say ampersand a. So to whom it should point? It should point to over. Then third step. Reference is created. Reference assign a. Guess, can you write like this? No. Why? See, declaration initialization. But in case of reference, declaration initialization is not possible. This is not allowed. It should be like this. It should be declaration and initialization combined together in a single line. That is must. Okay, that's a new thing you learn about this one. Reference you saw. What is reference? I have explained you. It's just another name. So next, I am showing you that reference cannot be broken into two statements, declaration and initialization separately. It should be in a single line only. Single line only. Because reference is nothing but nickname, alias, another name given to you. Okay? Understood this one? No, 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 no. Only at the declaration time you should write ampersand in the reference. Okay, very good question. The syntax is such that only at the declaration time you'll write ampersand r. After that, just you use r. You'll never write ampersand at all. Like in pointer, you write asterisk. Then for dereferencing, again you say asterisk. For dereferencing, again you say asterisk in pointer. But for reference, nothing. At the time of declaration only you write r. After that, just you say r, 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 r. It means a only. So next line you cannot do ampersand at all. So declaration and initialization of reference must be in a single line. It cannot be broken into two lines at all. This is a very important point. All right. So that's the reason. See, when you pass A from here, that is taken in R. That's all. After that, just you are saying R, R, R. All right. Now, let me finish. What I was telling here is R is a nickname. All right. Suppose there is one person whose name is Rajesh. Okay, his name is Rajesh. Int Rajesh. Okay, let us give a nickname to him. Raj. Let us give a nickname. So can you break it in two lines? Let us call him Raj. To whom? Next line you will not say that. No, let us keep the nickname. Later we will decide. No, no. Whose name? So you must say, let us call Rajesh as Raj. You must tell it in the same line only. I need an address variable. Okay. Whose address you will keep? We will decide later. I need a data variable. What you want, what value you want. We will decide later. It will have garbage right now. Okay, let it have. Later on, we will decide. We'll give a nickname. To whom? We will decide later. So this doesn't happen practically, isn't it? So when you give a nickname, you will have a person object in front of you, definitely. So that's why it should happen in a single line only, in that sense. Now you have related with the real analogy, so you got that point now. All right, finished. It's of same type, na? It's of same type. See, you should declare a variable of type reference, then you should assign it. You are saying that we should be able to write ampersand assign A, and it should automatically understand. That is your C++ compiler. Okay, he is saying that it should have understood like this. So, but they thought that it should give a variable name. It should ask, what is your variable name? It should take the same variable name. Why we should write it? So that's a different thing. But they have given the syntax, you should declare it of with same type and they should assign it. Haha, yes. Yes, it will not consume any memory like pointer. It will not consume any memory like pointer. No, no further question. This you got the answer right. That is my question actually. That is my question. Okay. It will not consume any memory. Okay. Chalo. Now I have a question. Can this function access the activation record of main directly? Can this R directly access the activation record of main? But just now I explained you, one function cannot access the activation record of another function. Just now I told you. But what I am explaining here, that R is a reference or nickname to A, which belongs to some other function. Some other function. It's contradicting with the previous statement. All right. Understood this one? Got it? But in C++, they made it, implemented it. But actually, directly, it's not possible at all. Mechanism is not possible in the machine at all, right? So that cannot refer to the same variable at all. Directly, it cannot access. But in C++, we say it directly access. Now the question is, then how it is happening at the back? That is your research work. You do research on it. You study you and find out and tell me in the next class how it is doing at the back. But it is directly accessing. But one point is important. One function cannot access the activation or the variables of another function directly at all. But here in C++, we are saying that R is a reference to this one. So it's another name. It will directly access and R will not consume any memory at all. This is the description that we find in the text of documentation of C++. All right. Then how it is possible? Technically, it's not possible because for every function, activation records are created and they are separate. They are separate. Boundaries are there. Technically, this is what happens. So this is in every language. In C++, it's no way different. So activation record is created for another function also. Then how it is accessing directly? That you find out. Understood this one? Over. Answer you have to find out. So next class, it's like a homework. Okay, if you want, we will discuss in the next class what may be happening at the back. Okay? Understood? Understood this one or confused? Is it clear? Sure. This was the question somebody asked online also. So I wanted to raise this as a question and explain you something. So it's a homework now. All right. So ask ChatGPT how reference work inside, how it can access directly. So it will discuss with you. So finished. So we have seen 3 parameter passing methods. Now using these 3 methods, there are a lot of gate questions are there. So I'll try to pick up few questions and solve them. All right. So that along with this topic only, you are solving few gate questions. Then after that, we have to see pointer arithmetic and pointer upon array and pointer on 2-dimensional array. Many things are there. So this is a lengthy topic. A lot of questions are there. Okay. I'm writing few gate questions here. This is from 2026. And actually, it's not related to parameter passing. There is a program integer a assign 5, integer main. The simple question only. A assign 7, return 0. There is another program int main, int a assign 5, a assign 7, return 0. And there is one more program P3, that is int main, int a assign 5, float a assign 7, return 0. Question is, which one of the following statement is true? A, P1 will compile without any error. P2 will compile. B, P2 will compile without any error. C, P3 will compile without any error. D, all will compile without any error. Simple one, simple question only. Either you read it from the board and answer it, or else copy everything, then read it from your notes, then answer it. Acha, any problem with P2? What is that? You cannot have two variables with same name. You cannot have two variables with same name. No, no, no. You are again saying int, na? Two times you are saying that. So actually you are learning also something here. Actually you are confirming something here. You cannot have two variables with same name. Problem with P3? Any problem or works perfectly? You are declaring two variables with same name, whatever the data type may be. No, you cannot have two variables with same name. It's a simple thing, na? Why you are confused? This is the first thing that you learn in programming. A program cannot have, or a function cannot have two variables with same name, whatever the data type may be. See, you are declaring int, declaring float. You cannot declare two variables with same name. Int, no. Same data type also you can't do, different data type also you cannot do. What about this one? Because that is a global variable, this is a local variable. When you access assign 7, or if you say print, I am writing here, print A, whose value will be printed? 7. That will be shadowed. Global will be shadowed, hidden. But in other functions, if they don't have same variable name A, it is visible there. In this function, it's not visible. So you write down in the description. Actually, this was a simple question only, but you learn one thing, that you cannot have two variables with same name. You cannot have two variables with the same name, even if they have different data type. But you can have global and local variables with same name. And the global variable will be shadowed inside the function. Shall we move next? Void f int star p comma int m. M assign m plus 5. Uh, m assign m plus 5. Star p assign star p plus m. Return void main. Int I is equals to 5. J is equals to 10. F ampersand I j. Printf percentile d I plus j. So what will be printed or what will be the output of this program? There is only one printf. What is the output? So this is 2016 gate question. Numerical type question. No options. I assign 5, j assign 10, ampersand I and j. So one parameter is passed by address and one is passed by value. This is a pointer and this is a normal variable. So you can mix the parameters also. Ah, right, correct. Lokesh, Gupta, Adrija. Yes. This was simple. What's the answer? 30. Yes, perfect. Answer is 30. You want me to explain? Ah, okay. All of you got it? Okay, as this was the first one, I will try to trace it also and show you. See here, you have I that is having value 5, and you have j that is having value 10. And when you are calling a function, p is a pointer that is referring to, from here you are passing ampersand I, so this is pointing to this one. And when you have m, that is having the value of j, 10. So m assign m plus 5, so this becomes 15. And star p assigns star p plus m. So star p means 5. So 5 plus 15, this is 20. So 20 is stored in star p. So this is modified to 20. Function ends, and if you come back here, it is printing percentile d I plus j. So 20 plus 10, I plus j, 20 plus 10. So this is 30. 20 plus 10 is printed. So that is 30. Oh, no. Yeah, here. Okay. Int a, b, c assign 0. And void, okay, I'll write as it is, that is given in gate question. This is from 2012. Void pt, okay, ptr fun, and it takes void. And main function is there. This is called as prototyping, right? you write on the function name beforehand, static int a assign 1, and ptr fun, calling a function ptr fun, then a plus assign 1, then calling ptr fun, then print, I'm just writing print here, a and b. And if you see ptr fun, the function is written here, ptr fun void static int a assign 2, int b assign 1, a plus assign b, a plus assign plus b, print a comma b. Is it an incomplete question? Yeah. हम्म हाँ, एक्चुअली मेन के बाद अगर फंक्शन लिख रहे हो आप, तो मेन से पहले उसका सिग्नेचर आना चाहिए, प्रोटोटाइप आना चाहिए. Because compiler, when it compiles, it will start from first line onwards. So when it finds ptr fun, what is ptr fun? It's given below. So C compiler will not go there. So it should already have the name of the function in the beginning. So you will write prototype, then you write down the function later on. This is the method in C language. (42) option A, 42, 4 values, na? Hmm. Okay. Yeah, nahi. ptr fun is called 2 times. So total 6 values we want. Hmm. 42 or 42? 42, yeah. 42. Option A, 426220. Option B, 326260. Option C, Hmm. Shall I trace it? 426220. Yes, correct. See, A, B, C, three variables are created. C is initialized to 0. What about AB? 0. Why 0? Global variables. So, global and which variables are automatically 0? They will not have a global and static. You remember this? Other variables will have garbage, but global and static variable will have a value 0. By default, they will have 0. Okay. So this point I told you, but now you are looking at it. So we have not done any program or on that, but now you are looking at it. So global and static variable by default, they will have value 0. So they are all 0. Now, next, let me explain you the code. See, in C programming, it will start from the beginning, compiler. So when it come across PTR fun, it will say, what is PTR fun? So function is defined below this main function. So it will not go there. It will they stop there only and say error. PTR fun is not defined. So same way, let me tell you one point. Same way, if a printf is used, it will say, what is printf? Undefined. So that's why you have to include in the beginning stdr.h. But that is taken as a default library. So without that also it may work. So that is the reason we include the library. So it will go to the library and check. If not in the program, it will go to the library and check for what? Just the name of the function. It doesn't need the entire function. So only the prototype of a function it needs. So that's why we have written the prototype. Detail function is given here. So this is the C style of programming. But in latest compiler of C, you don't have to write prototype. Without that also it works. All right. Now coming to this. So the function is defined later on. Now let us execute it. See static A. So this is having its own A, which will have the value 1. Then you are calling a printf function. So ptr fun function. ptr fun function is having its own value A, which is static. This is 2. And it's also having value B. And this is also having value 1. Then plus plus B added to A. So plus plus B means what? This becomes 2. And that 2 is added with A and store the result in A itself. So this becomes what? 2 plus 2 becomes how much? 2 plus 2 is what? 4. So 4 is stored here. Then print AB. So first output is what? 4, 2. Let us put a comma to show it separately. 4, 2, 1. Till here completed. Is it clear? So was it easy to read this line? I have not covered operators and all, so I'm assuming you already know this one. So A plus assign plus plus B, right? Now, control goes back. Here, A plus assign 1. So whose A will change? This A will change. So this becomes what? 2. Whatever the value of A is plus assign operator. This is plus assign 1. So its value is taken and that 1 is added. So it becomes 2. Then again print fun, PTR fun is called. So in PTR1, as this is static, not declared again, this int B assign 1. So again B is freshly created. So B is freshly created. So what happens? B is created once again. Oh, I was taking green color here. Uh, B is created once again here with 1. Then B plus 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 B. So this becomes 2. And that is added with A and the result is stored in A. So this is 2 plus 4. So this is 4 plus 2 is how much? 6. And this becomes how much? 6 now. This is the new value. This is the new value. 6. Now print AB. So what is A? 6. What is B? 2. So 4 2 6 2. This is over. 4 2 6 2. Now function ends, control goes back. Now print AB. So what is the value of A? 2. So 2 is printed. What's the value of B? It's not changed at all. It's as it is and its value is 0. So 4 2 6 2 and 2 0. This is the result we have. All right. So next one, a simple one, but the possibility of doing a mistake here. Void fun integer star p comma integer star q p assign q star p assign 2 int I assign 0 j assign 1. I and j are which type of people, which type of variable? Global variables. Ampersand I and ampersand j. Print I and j and return j. Get char is also there. No need of that. Get char means it will wait for you to hit anything from the keyboard. So what is the output? Just return 0. Return 0. Main also we write return 0. ठीक है, अच्छी बात है। आप चले जाइए ऊपर। है। हाँ हाँ। हाँ हाँ हाँ, अच्छी बात है, ठीक है। ठीक है। ओवर। व्हाट इज द आंसर? 2 comma? I told you already, this is simple one, but you may do mistake here. I should not get multiple answers. I should get only one answer. 0 comma 2. Global variables I is 0 and j is 1. J is 1. Function is called by passing addresses of these. But actually, these are the global variable. They can be directly accessed. But still, you can also pass the addresses to the other function. So it will access them through this one. So this is P, and this is accessing this, and this is Q, which is accessing this. Now, first line is P assign Q. What happens? P assign Q, address of P is also an address, Q is also an address. So address of Q is given to P. So P will also point on J. It will not point here. J. Now next line is star P assigned to whose value will change? J value will change. Now function ends, you come back and print ij, 0 comma 2 is printed. Here 2 is there now, so where this 2 is gone? 2 is stored there. Yes. I have one more function. No, sorry, one more gate question is there. Ah. Then after that, we'll move on to other topic. Hmm. Int function fun, which is taking the parameters n and also taking star f underscore p, and it is having the variables integer t and f. And if n is less than or equal to 1, star f underscore p is equals to 1, return 1. Yeah. Sorry. Yes. If so and so, star f underscore p is equals to 1, then the return 1. Just the readability for reading the code is difficult. Otherwise, the program is very simple. F underscore p, so that looks little odd for reading. The function is very simple. The code is very simple. Then t assign function fun, calling function fun for n minus 1 and p underscore. So it is calling itself means it's a recursion. So recursion along with the pointer that you are looking at. Plus star f underscore p. Then star f underscore p assign t. Return f. Now from main, I'm just writing this call here. I'm not writing the complete code here. No space. Otherwise, I should write there. So you have to find, okay. Sorry. Now I must write down here. So I'll do one thing. I'll select this one and make space here itself. Yeah. Main, this is having one variable, integer x assigned 15. And you have to find out what will be printed if the function is called by passing 5 comma ampersand x, address of x. That's it. If n is less than equal to 1, star fp assign 1, return 1, and it is calling recursively, fp is pass and t is assigned star fp assign t, return f. Main, yeah, perfect. Let us see what is happening online. Yeah, for the previous two questions, I did not check your answers. 30 was correct, and A, okay, 42, 62, and 20. I have done the tracing. Hope everybody got it. Then 0, comma 2, for that also have done the tracing. Everybody got it. Star is missing in the recursion, in the recursive call. I'll check it. No, while calling, you don't have to say star. Just you have to pass the pointer. You have to pass the pointer. You're not passing the value. See, this is taking an address. So FP is a pointer. So it's passing pointer. X is 15. So recursion plus pointer, two things together. X is having value 15. Function is taking value 5 and X, that is a, sorry, so uh, FP, I'll just write direct FP, that is a pointer to this one, X, pointer to this one. All right. So if n is less than or equal to 1, just two steps are there. Otherwise, it's calling recursively. What is that? T assign, it's calling itself by 4 comma FP. I'm writing FP only. FP is a reference to this one, pointer to this one. So again, it will call itself T assign F of 3 comma FP. Other steps we'll do later on. Here I'll expand them. Then T assign F of 2 comma FP and T assign F of 1 comma FP, and less than or equal to 1 means FP assign 1 and return 1. T assign F of 1 comma FP. When this is 1 means FP is assigned 1. FP is assigned with star FP assigned 1 means this becomes how much? 1. And return 1. So the result of this function becomes 1. So what is the value of T here? T is how much? No. Return 1 now. T is how much? 1. T is 1. T is equals to 1. I am writing in here. Are you doing it like this only? So then what are the steps? Next step is T plus assign star FP inside F. And that T is stored in FP. T is stored in FP, next step. So these two steps are little independent, right? T assign in the FP. But value of FP is used here, sorry. Value of FP is used here. So T plus FP. What is that? 1 plus 1, that is stored in F. So F assign 1 plus 1. The next step is star FP assign T. So the value is a change. Star FP assign T. So star FP assign T. So this will become what? 1. Still 1. Then the last step is return F. So what's the value of F? 2. 2 is return. So 2 is return means the result of this function is how much? 2. So what will be the value of T here? 2. Now you continue the steps. Have you got it? You got the answer? No? Okay. I'll finish it. Now, you have to remember the steps. T value we got. Then T plus FP should be in F. T plus FP should be in F. T is how much? 2. 2 plus FP is what? 1. That is how much? 2 plus 1, 3. 3 is in F. All right. And then FP assign T. In FP, you have to store the value of T. T is how much? 2. Then return F. So what is the value return? F is how much? 3. 3 is return. So what is the result of this function? T, 3. Now again go back to the previous line. Now T is 3. Next line is T plus FP. So 3 plus, this was 2, right? 3 plus 2 is how much? 5. So F becomes how much? 5. And FP assign T. So this becomes how much? 3. Then return 5. Return 5. So this T value is how much right now? 5. T value is 5. Now the next step is again, in this you have to take the steps. So T plus FP assign F. So F is how much? 5 plus 3 is 8. The next is FP assign T. So FP is this one only X, right? So this becomes 3. Sorry, this becomes 5. Then next is return F. Return F is how much? 8. So this becomes 8. So the result of this function is 8. This is the answer. So what was this? Any head or tail, any useful function? Nothing. So what he was trying to see by giving this gate question, what he was trying to see, Do you understand the syntax of pointer? Do you know recursion also or not? Two things were tested here. All right. If you have not done it now, it's a homework. You spend time on it and do it by yourself. You must repeat it. You must repeat it. This is one of the difficult question you can say. All right. Any question? Star underscore f underscore p f underscore p f underscore p f underscore p. Same thing I'm using. F underscore. No, it is like this actually. Star f underscore p. That's what this is. Readability. In the beginning I told you, for reading the code itself is difficult in this question. Three things are there. Pointer is tested. Pointer is tested. Listen. Pointer, recursion knowledge, and unnecessary lengthy steps are given, so that can you keep them in mind and process them in every call. There is no end result is of no use. We can't say that this function is useful for something at all. Just they want to test on this one. And even they make the name of the variables also difficult, so that you cannot easily remember them. So it will waste your time. This type of code will waste your time. All right. So this type of questions are also there. So they intentionally they give the variable name something difficult. You can't keep it in mind or read it properly. So readability is low in this code. All right. Now you should practice this one. Now I was not expecting an answer from this one. Anyway, if you have done it, it's okay. Otherwise, you practice it. Now next, this question is simple question. You must give correct answer. You must give correct answer based on yesterday's discussion. Based on yesterday's discussion, you should give correct answer. All right, I'm writing the code. It's a gate question. Watch here. Don't copy anything. Void swap integer star x comma integer star y star x comma star y. Integer temp assign star x and star x assign star y and star y assign temp. Are you familiar with this code? This is for swapping two numbers. For swapping two numbers, you must take call by address only, and you have to write down a star star everywhere. You're familiar with this one, right? Understood? Now, if you compile this piece of code, for main is also there, suppose, and whatever is there in main, everything is perfect. Now I'm asking questions, you should answer them. Okay? If you compile this program, will you get any compilation error? Main is perfect. Okay, I have not written. Will you get any error? No. Will you get any error? No. Next question. Will you get any runtime error? Take your time. Compile error, you said no. Okay. I have just asked, don't answer. Don't answer. Will you get any runtime error? Okay, I'll make it little easy for you. I have not given options. If I give option, you will identify it. Okay. You will say, look, this is the correct answer, but I have not given option. So I want that option from you only. So the point is, once again, I'm repeating, will you get runtime error? And if your answer is yes, then why? If no, then why? Take your time. When I say, then only answer it. You have already discussed this yesterday. We have spent a lot of time on this one. Yes, some of you got the correct answer. online students. Adrija and Venkat got the correct answer. Yes, very good. Come on, why you don't look at the code? Code will not tell you anything. Huh? Why you get runtime error? Yesterday we discussed about runtime errors. Recall that and try to relate it with here. In what cases you get runtime error? Huh? Uninitialized pointer and dangling pointer. When the function is called, is there any chance of getting runtime error? Who will call? Is it called right now here? From wherever it may be called, there is a chance. Whatever the values are passed, it depends on that. So is there any chance that invalid recursives are passed to the function or not? Yes or no? I am calling it from the main. Main. Integer star x star y swap x comma y. I don't have to say ampersand because already I have pointers. I'm passing those pointers. Okay, I'll just change them names here. A comma star B. I have two pointers. I am passing those two pointers. Pointers will be copied in those pointers. Which pointers these are? Uninitialized. I am giving to that function and it is using star x means what? Error or not? Which type of error? Runtime error. So function is not having any problem. But how you will call the function by passing what values, it could be a problem. When you call a function, what values you pass, that may cause problem. So now the question is there any chance of runtime error in this function? Yes. Yes. This is a great question. In options are there, will it give compiler error? No. Will it give so and so error? No. Last option is will it give runtime error in case of some parameters? Yes. You read it, you will understand it, you will recall it. But I wanted the answer from you, directly from you, without showing you option. Now, one thing we learned, whenever a function is taking some pointer as a parameter, there is a chance of a random error in that function. Do you agree with this one? Now this become a global statement now. If a function is taking pointer as a parameter, then there is a chance of runtime error in that particular function because how you call it, it depends on that. If you are irresponsible and you're passing some uninitialized pointers or dangling pointers, then that function will cause error. So copy this one and write down all the explanation. This is very important. Based on this point, multiple questions are there. There is no syntax error in this one. But if a pointer is not passed properly, it will cause runtime error. If dangling pointer or uninitialized pointer is passed as a parameter to swap function, it will cause runtime error. So note, it means that any function which is taking a pointer may cause runtime error, may cause runtime error. So it is vulnerable to errors. Yeah. Over. I have one more interesting gate question similar to this one, and you must answer correctly. When I say, then only you should answer it. Star PTR A, int star PTR B, int star temp, then the temp assign PTR A, PTR A assign PTR B, PTR B assign temp. This is from 2016. Main 2016 B assign 0, C assign 4, D assign 42, mystery ampersand A comma ampersand B. If A is less than C, mystery ampersand C comma ampersand A, mystery ampersand A comma ampersand D, print and sorry, print A. What will be printed by this function? There is only one print, so that is print A. What will be printed? So when I say, then only answer it. In this question, they are trying to check, are you able to read the syntax properly or not, or do you really know the syntax or not? Just they are checking that. Like here I have told you, in the previous one I have told you what they were trying to check. So they made the question little complex. This is simple only. This is simple, not difficult question. But they are testing whether you are able to read the syntax and understand the syntax or not. If you don't understand, you will give a wrong answer. If you understand, you will give a correct answer. So when I say answer, then only you have to answer. And always don't start tracing, read the code, understand, and then start tracing. Always, for every question, read the code thoroughly, understand it, then trace an answer. There's no recursion, just simple steps are there. Luckily, you have a hint on the board itself. Some are copying. If you have read the code thoroughly without moving pen, you can answer it. Luckily, you have a hint on the board itself. Interesting question, very interesting. Simple. Chances of giving wrong answer, right? Chances are there. What is this code for? What is this code for? Come on, you are joking. Again, what is this code for? Swapping values, data. What is this code for? Does it affect anything with the data? No. Will it affect the data? Is it swapping the data? No. But when you are tracing, are you swapping the data? Addresses you are swapping. Actually, if you swap addresses, will it change the data? No. What is the answer? Yes, 2016. A is greater than B, C, C. Whatever you do, addresses are being changed. That is inside the function, not here. Huh. Pointers are swapping. Data is not disturbed at all. That's it. So once you realize that this is not changing the data at all. So whenever you are passing the address, they are playing with the address, not changing the data at all. So data remains same. So the answer is 2016. Correct. So from here you can realize that from this you can easily make out uh, there is no swapping done. Understood? Now if you are guessing that if the addresses are changing, something may happen, then you trace it and check. Right? If you're not sure, then do it now. Later on, you are confident that if the addresses are changing, nothing happens. Okay? If you are tracing addresses, do it. Finish it. That will give confidence to you. Okay? So this was interesting question. Answer is, see, the hint itself is there. This is asked in 2016 and the value is having variable 2016. Usually there are some questions also, previous questions are there. In the same year, they have given one value at one variable and the output is same. Now one more hint, shortcut. So variable name is 2016 means the answer could be 2016 only. So with that way you can finalize, oh, what's the answer? Yeah, you can check the code. Yeah, this is over. Now, actually, I'll just come in a minute. Huh. Now, see, we started with the pointer, we learned with different things, then learned today we started with parameter passing methods, and using that we have seen some example git questions. And I told you that some questions are there, they are giving reference also. We have not covered those questions. I have covered few questions only. There are a lot of questions using pointers, using parameter passing methods. A lot of questions are there. So we'll do them. But they are mixing with arrays also or double pointer also. We have not covered them. So few questions only I have touched. All right. This is a major area. One area was recursion. The other area is this one. Then loops and operators are very few questions are there upon that. So that's why I'm covering at the end. I should start with operators in C, but I will end with operators. Okay, so let us look at this now. Next topic is uh, pointer arithmetic. Pointer arithmetic. Okay. For explaining pointer arithmetic, first of all, I will create one array. Watch this one. I'll create. I'll create one array. A is an array. Indices are 0, 1, 2, 3, 4. And the addresses, let us assume the address is 200 and 202, 204, 206, and 208. 206 and 208. And values inside this function are 2, 4, 6, in this array are 2, 4, 6, 8, 10. Just watch, just listen. You don't have to copy anything. So this array I have created like this. Integer array of size 5, and this is initialized with 2, 4, 6, 8, 10. All right, this is done. Now I will take one pointer star p as well as one more pointer star q. I have to actually explain pointer arithmetic, all the arithmetic operations upon the pointers. But for explaining that, I need a setup. So that is, it works along with arrays better. I can explain through arrays better. Okay, so for that I have created an array. Now let us understand the array a little bit. See, this is the name of an array. When you say a of size 5, array of size 5 integer is created, and also you are giving the values for initialization. They will also get initialized, and 2, 4, 6, 8, 10. And this is called as the base address of an array. This is called as a base address, that is 200. Then as we are saying that integer take 2 bytes in our explanation, I am taking integer takes 2 bytes. So the next integer is at 202 and 204, 206 and 208, so on. 2 bytes are taken by them. All right. And they are contiguous memory location and contiguous memory location, one beside another. All right. Now I have two pointers, P and Q. Now watch this. I am writing the syntax. Watch here. I will say P assign ampersand A of 0. Means what? Address of first look assigned to P. So P will be pointing here and its address is 200. Directly I have written, I am not showing the box, directly I have written it, 200. Now same thing, you can also say P assign A also. P assign A also you can say. A means the base address of an array. All right. So two way you can do it. Now I will take Q also and I will say ampersand A of 4. I will say this. So Q is pointing here, that is 208. Now setup is ready for explaining pointer arithmetic. Setup is ready for explaining pointer arithmetic. So I have an array, I have two pointers P and Q. P is pointing on the first element and Q is pointing on the last element. All right. Understood this one? Now, let us start pointer arithmetic. So for that, first of all, you tell me what are the arithmetic operations? Plus, minus, multiply, divide, mod, and you have plus assign, minus assign, multiply assign, divide assign, mod assign, assignment arithmetic also, and arithmetic related only operations you have plus plus, minus minus. These are the arithmetic operations. When you say arithmetic, these are the arithmetic operations. All right. Now my question is addition, subtraction, multiplication, division, and mod works on which data types? All these work on which data type? Integer. Integer. In C language. On float, you can add, subtract, multiply, divide, and mod. Can you perform on float in C language? No, mod doesn't work on float. Now, plus, plus, minus, minus, will it work on float in C language? Plus, plus. No, no, it works on integer. So it means all arithmetic operator doesn't work on all the data types. All the data types. You agree with this? Now, similarly, all these operators, all arithmetic operators doesn't work upon pointers also, right? So you should agree that some doesn't work means you should not argue why, sir. So for float also doesn't work. Can you multiply two strings in C, C++, or Java? Up till there also you cannot multiply. But in Python you can multiply. Not string, with constant you can multiply. But in C, C++, it doesn't make sense. It gives an error. So all operators cannot be performed on all data types. Same way, on the pointer also, only few are allowed. So what are those? I will highlight them. You can, nay, 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 nay. You can perform plus plus. You can perform minus minus. You can perform plus plus. You can perform minus minus. Right? And you can perform just minus, nothing else. Now, here I'll make a list separately. Here I'll make a list separately in red color only. You can say P plus plus. You can say P minus minus. You can say this one. You can say P plus assign some constant value K. Constant. So instead of K, I will say constant. You can say constant. Not pointer. Not pointer. You can say P minus some constant. And you can say P minus Q. You can subtract two pointers. You cannot add two pointers. You cannot multiply pointers. You cannot divide pointers. You cannot add two pointers, but you can add a constant value to a pointers. So these are the operations that are allowed in on pointers. First, second, third, fourth, fifth. So, all right. So you don't have to copy anything. I'll keep this list. Now, I have a space here, so I'll keep it here. Hmm? Let us continue our discussion. Then, now, first operation we will see. If I say P plus plus, what happens? P plus plus. See, what is the address of this one? 200. Plus plus means plus 1. Plus 1, right? No. Plus plus means not 1 in CC plus plus. Plus plus means next. Plus plus means next. If you have integer 5, plus plus means next. So what's that? 6. Now I have changed the meaning of plus plus. Till now you know that plus plus means it will add 1. No, it will not add 1. It will take the next integer. That's why on float, there is no next float because you have infinite float values, right? So there is no plus plus in float. But integral part, you have next. So same way, P plus plus means what? P is a pointer of type what? Integer. So plus plus means next integer. So P should move to 202. 202. Let me finish. Let me finish. Understood this one? So this means what? Move P from, oh, to next integer from 200 to 202. 202. All right, just you have to listen. I have to finish the topic, then I'll give you the points. Okay, let us finish. Now, same way, second one is what? Hmm. If you say p minus minus, p minus minus, I'm not modifying it there. P minus minus means what? Previous. So if I say, okay, p minus minus, move p to previous integer. Suppose it is at 200 only. If you are assuming 200 only, then it will go to, come on, 198. It will move. It will move. It's a pointer. Okay. It will not see that allocated or not allocated, nothing. Now, if you say star p, no, 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 no. 198, is it valid here? No. So if you say star p, then runtime error, runtime error. So you can move. Otherwise, I should have taken this at a of 1. So I can move this way also, that way also. Okay. Anyway, now I have understood what does it mean. So you can say p plus plus also, you can say p minus minus. Two things you can say. Now, next, third, you can say p plus 2. P plus 2. Read it. P plus plus means P itself will move. P minus minus means P minus its P itself will move. Just P plus 2 means P will not move. This is not plus plus minus minus. In P, you add 2. Add 2 means it will give the address of an integer that is 2 locations away from P. So right now P is at 2000, so it will give, sorry, 200, so it will give 204. So you get the address of that location. That's it. Now, you can assign it to any other pointer. If you say p assign, then it will modify p. Or else if you say q assign, it will modify q. If you say r assign, it will modify. It will store it. Now, you can take it in any other variable. This will not modify p itself. Okay? This will not modify. But see, p plus plus means you are getting next address. P is also pointing there. P minus minus means you are getting next address and P is also pointing there. P plus 2 means you are getting the address 2 locations away, but P is still in its own location. That's all. That's simple. Now, same way, fourth is what? You can say Q minus 3. So means what? Similar. It doesn't modify Q, but gives the address of integer 3 location away from Q in backward direction. Forward. 2 location away, forward from P. Forward from P. And this is backward. Understood this one? 4 operations I have shown you. We will use them in examples to get the concept perfect. Okay. Now, last operation is pending. What is that? I have shown you that plus plus minus minus constant and minus constant, and last is P minus Q. Now, fifth one. So you can say Q minus P. This gives what? 8, 200. 208, 200. Who is saying 4? You are saying, okay. No, not 6, not 6. 8 or 4? 8 or 4. Okay, though 2 are, I will take 2 answers. Okay. But 8 means literal subtraction. But the question is why you want to subtract 2 pointers? Guess. Flat number to 10. Flat number 215. Subtract 215 minus 210. 5. So what you came to know? How many flats away? That's what, right? So same way, what you want to know here? How many integers away? So what is the right answer for you? 4. Yes. If give the answer 4 gives number of, sorry, gives, huh, gives distance in terms of data items. In terms of data items. Huh. Actually, it's not pointer. It's not subtracting integers. It's subtracting pointers. So it will also divide it by 2 with the data types. With the size of the data also, it will divide it. Size of the data is 2. So we are assuming 2. So it will divide it by 2. See, subtracting 2 integers and subtracting 2 floats, is it same or different? So subtracting 2 pointers is also different. Okay, it's not integer subtraction. Huh. Yes, divide by 4. Yes. Yes, correct, correct. Depends on the data size. Now, I have some more thing to explain. Watch here. This is just I have explained you what is what. That's all. All right. Now, one thing. I have a integer pointer p1, and if I say p plus plus, sorry, okay. If I am saying p1 plus plus, then if I have a character pointer p2, if I say p2 plus plus, if I have a float pointer p3, and if I say p3 plus plus, now integer pointer move by 2 bytes, character one, float. So how much the pointer will move and how this operation works depends on the data type of whose pointer, data type of a pointer. So it means arithmetics depends on data type of a pointer. So we saw yesterday, dereferencing depends on the data type of a pointer. Now we learn one more. Pointer arithmetic also depends on a data type of a pointer. Data type of a pointer. All right. So we are assuming this as a 2, this is 1 only, this is 4 only, standard. This can be 2 or 4. So we are taking 2. So pointer, integer pointer move by. So every pointer will perform pointer arithmetic depending on its data type or the size of the data type, size of the data. So this explanation we can note down. P minus 4 here. Achha, okay, you are saying Q minus, So Q minus P. So Q minus P, larger minus smaller. If you change it, smaller minus larger, it actually depends on the compiler you are using. So, but most expected value is minus 4. So with that, what you can make out? Which one is nearer, which one is far? Okay, you can find out this one. If you are getting 4 always, then you should check their addresses and find out who is farther and who is nearer. So expected value, what I have tested, I got it as minus 4 on Turbo C, not on Linux or Unix. I have not checked it. Long back. Subtraction. Hmm. Addition should also give integer. No, that doesn't make any meaning now. Adding two pointers. No, it may give the result, but that doesn't make meaning, give any meaning. It will add addresses then. Adding addresses will give you some other address. Hmm? No, no, it doesn't. Even I thought this way, but it doesn't work actually. These operators give you syntax errors. If you use plus, p plus q or q plus p, you will get syntax error. Operator is not supported. It's not random error, syntax error. Compiler itself will reject. It will say, no, I don't know how to add two pointers. Now, if you want any logical answer on that, then flat number 215 and one more flat number. This is Sharmaji flat, okay? And this is Varmaji flat, that is 210. If you subtract, you'll know how many flats away, apartments away they are from one another. Okay? Logical reasoning I am giving. Acha, subtract giving meaningful result. If you add, this will be 425. Whose flat number you'll get? Gupta ji flat number. Whose flat number you get? So it's meaningless to add two flats, flat numbers, door numbers. If you subtract door numbers, it making sense. So actually, it's a syntax error. Compiler allow only these operations. Oh, sorry. Compiler allow only these operations. Other operation give syntax error. Compiler itself will reject. Hmm. So as it has rejecting, so I found a convincing answer that Sharmaji, Varmaji subtract, its answer is correct. But if you add, you will get meaningless results. So okay. So that's all. Now the next topic is pointer to an array. Pointer to an array, that is single dimension array, two-dimensional array, pointer to a pointer, that is double pointer, that is also there, and pointer to a function. So pointer to this, pointer to that, there are many things. And two-dimensional array, the topic is little lengthy for explanation, and there are some gate questions upon it. So this was just the topic that you have learned, that's it. So directly it's not useful, direct the questions, but in other questions, arithmetic is also used. So pointer arithmetics works along with array only. So I prefer stopping here today. So next class will be on Monday, nahi? Next class, my class will be on Monday. Otherwise, if I stop in the middle, it will be 2 days gap. So from Monday, we'll start all the operations and then we will see gate questions in the next week. All right. So at pointer arithmetic, we have stopped. Any questions from online students? I'll check. Okay. Thank you. Okay. Right. So we are closing a session.